kilohertz. So when you sample it, you have to sample it with at least twice the highest frequency, that is 40 kilohertz. Normally you sample with 44.1 kilohertz. So audio sample sampled at 44.1 kilohertz may need to be resampled to some other rate. For example, if you are passing it through a telephone cable, which may have, say, 4 kilohertz bandwidth, you may need to resample it to some other sampling rate, to a lower sampling rate sometimes, or to some higher sampling rate also. Sometimes you may need to convert it to, say, 96 kilohertz and all. This kind of higher frequency samplings are used in CD quality uh, data. So mostly you may need to convert a sampling rate from one to another. So what you normally do in such cases, you require the analysis required for that. How to convert one rate of sampling to another rate. So it could be a integer sampling conversion. It could be a fractional sampling rate conversion. For example, uh, if this may be converted to, say, 3.5 times of this frequency range. So this is fractional change. So it is done by 2 fraction change. So you may need to upsample by 7 and downsample by 2, etc. So let us see what these basically are. So let us see what is upsampling and downsampling. When you have a signal, say discrete signal like this, so 1, 2, 3, 4, 5, 11, etc. 3, 1, 2, 1, let this be 4, 1, 2, 3, 6. Okay, this kind of data, 1, 1, 3, 1, 2, 3, 1. Okay. This is your N. This signal is your Xn. When you sample this signal, so suppose you sample this signal at particular sampling rate. Suppose you want to downsample this, downsample by a factor of 2. What does that mean? You have some sampling rate. If you want to downsample it by a factor of 2 means you are now going to decrease your sampling rate. You don't need all the samples that you have taken. And if you are downsampling by a factor of 2 means you just require intermediate data. For example, you require this, then you don't require this, you require this, like this. So basically, your new signal will be 3. At 0 you have 3, at 1 you have whatever you have at 2, that is 2. At 2 you have whatever is at 4, which is 4. At 3, whatever you have at 6, that is 1. Okay. And at 4, you have whatever is at 8, that is 3. Like this, you have the values. That is, xn is downsampled. You represent downsampling like this. Then you get, suppose you get yn, then this is the yn. You take the samples in between. First you take the 0th sample, then you take second sample, 4th sample, 6th sample, 8th sample, etc. Then it becomes yn. So this is the fundamental of, or this is the concept of downsampling. Now what happened in upsampling? So in this case it is in the discussion of downsampling, we discussed downsampling by a factor of 2. Suppose the downsampling is by a factor of 3, then what will you do? Basically, you require, suppose this is a factor of 3, then you take first value and let us represent it as y1n. So how will be y1n? To take first value as such. First value will be in this signal. First value is 3 itself. At 0 you have 3. At 1 you have whatever you have at 3. So here you can see that at 3 you have a value of 1. So that 1 you write. At 2 you take whatever you have at the value of 6, which is 1 again. At 6. At 6 you have 1 again. Okay. At 3 you take whatever you have at value 9. That is 1 again. So that is downsampling. To take, if it is by a factor of n in general, you take the first value, 0th value, then you take nth value, then 2nth value, 3nth value, etc. Then you put those values at 0, 1, 2, 3, etc. Then that forms the n downsampled signal. So if you represent n downsampled signal as yn, if say capital N is your downsampling factor, here also capital N. Okay, then you get the downsampled version. Now let us see what is upsampling. Upsampling is basically the reverse process. For example, when you have an xn signal, say starting from 0, 1, 2, 3, 4, 5, etc. At 0 you have 1, at 1 you have 3, at 2 you have 6, at 3 you have 5, at 4 suppose you have 2, at 5 suppose you have some 7, at 6 suppose you have 3, like this. If you upsample the signal, upsample by a factor of 2, what is going to happen is your original signal at say n equal to 0 remains there. So n equal to 0 you have 1. Then what happens at the other instance? You have say at 1, n equal to 0 you have 1, n equal to 1 you have 0. You by upsampling, what you mean is you in intermediate values you take as 0 value. So at 2 you will take whatever you have at 1. So that is 3. You will take 3 here. Now you will leave 1 point. At 3 you have 0. At 4 again you have whatever you have at 2. So that is value of 6. Then at 5 you just leave 0. You don't have any value there. It's 0. At 6 again you have whatever you have at value 3, which is 5. And at 7 you can see that you leave it. You have a 0 value at that point. At 8 you have whatever you have at 4. So that is 2. And again you leave a 0 at 9, and at 10 you have whatever you have at 5, which is 7. Which is 7. Okay. So this is how upsampling is done. So this is upsampling by a factor of 2. Now if upsampling is done by a factor of say 3 for the same signal, what you do is you write the signal okay. At 0 you have the value 1. Then if upsampling is by a factor of 3, you leave 2 zeros. 0, 1, 2 will be zeros, and at 3 you add what you have at 1 position, which is 3. So you put 3 there. Then 4 and 5 should be zeros because upsampling is by a factor of 3. Then at 6 you have whatever you have it. The position C, that is 6. This 6 will come. Now you put 2 zeros. At 7 and 8 you don't have any value. At 9 you take the value at this position, third position, which is 5. I think there's some shoot or something. 1, 3, 6, yeah, correct. Then you have 5. So this is the upsample by factor of 3 signals. So if I represent this as say for upsampling, I write as YUN. Probably rather than Y1N here, it will be YDN will be better for representing it as downsample version. So if this is YUN, this is upsample by factor of 3. So if the signal is X of n and upsampling by factor of 3 is done, then you get this YUN. Upsample version. Similarly here, this is the upsample by factor of 2 signals. So if I represent it as YU dash n, then YU dash n is obtained by upsampling by a factor of 2. So Xn is here. You have YU dash n, which is upsampled by a factor of 2. So these are the basic upsampling, downsampling. Now let us see the equations behind this. For example, suppose you have say a signal Xn, which have these values 3, 5, 4, 2, 9, 6, 8, and at 0 you have this value 3. This arrow represents that this value 3 is at index 0, and at index 1 you have 5, index 2 you have 4, index 3 you have 2, etc. Now suppose you downsample this by a factor of 2, downsampled by a factor of 2. Xn is downsampled by a factor of 2. What happens? Suppose you get YUN. This downsampling by factor of 2 will make Xn. What is basically going to happen to Xn? If you take X2n, suppose you take X2n, what will be the signal? Can you try to draw X2n? You take n takes value 0, 1, 2, 3, etc. Then this becomes, for n equals 0, you have x of 0. So if y of n is x of 2n, for n equal to 0, you get y of 0 as x of 0. And when n equal to 1, you get put n equal to 0, n equal to 1. If you put n equal to 1, you get x2n. So x become x2, become x2. That becomes y of 1. N is equal to 1. So y of 1 is x of 2. So if you y of n is x of 2, so n equal to 2 means y of 2 will become x of 4. If you try to plot yn, which is the upsample version, or yun, let's represent that yu. YUN, then YUN will be YU0 is x of 0, which is 3. YU1 is x of 2, which is 4. YU2 is x of 4, that is 2. Okay, so like that it goes. You get 3,
Sir,
4,
it is
2, 6.
downsampling, right?
Yeah, yeah. This is downsampling. Yeah, we are seeing the equations for downsampling and upsampling. We just saw what upsampling and downsampling is. Now we are just seeing what are the equations. How do you represent the what are the equations governing this upsampling and downsampling? So first we are seeing downsampling. So this should be YDN. Is it what you are telling?
Yes, sir.
Yeah, correct. So these are this is the downsample version YDN. So if you take or if you're doing an downsampling by a factor of n, capital N, then the downsample version YDN is basically x of nn. YDN is basically x of nn. It is quite simple. The equation is quite simple. This is what basically happens when you downsample. Now let us see what happens when you upsample. How is the equation upsampling? Um, you know that when you have signal, say xn represented as 1, 2, 3, 4, 5, 6, 5, 4, 6, 3, 2, 1, 5. Okay, suppose this is the signal x of n. You know that upsampled version of x of n, suppose you can represent it as n by factor of 2, suppose. Then at 0 you have 5, then you have 0 at 1, at 2 you have value at 1, which is 4. Then intermediate values are not there. Here you have a 6, here again 0, here again you have 3, again you have 0 here. So at 0, 2, 0, 1, 2, 3, 4, 5, 6, 7, 8, etc. And at the point A, you have what at 4, which is the magnitude of 2. So this is the upsample version of x of n. The signal is this, but let us see what is the equation going in this, or how you represent it YUN in terms of x of n. So let us see. To take x of your signal is x of n. Your YUN can be, what could be YUN? It could be, can it be x n by m if m is the sampling upsampling rate? Here you have downsampling effect of n. So let us assume that upsampling is by a factor of m. Okay? If upsampling is by a factor of m, you need to upsample the signal by a factor of m. So you represent it by x of n by m. Okay? X of n by m. So how do you find, or suppose you have n equal to 1. Suppose m is say 3. So if I give n equal to 1, this will be x of 1 by 3, which is meaningless because x of n takes integer values only. X of n have some value only when you have integer inside. So you can represent this as x of this as x of yun equal to x of n by m for n equal to 0 m plus or minus m plus or minus 2m plus or minus 3m like this. And what should other values take? Y of 0n should be 0 for L. This can be written as x of n by m for n equal to 0 and 0 for all other values. For all other values. So will this work out? How can you write yun upsample version of n by factor of m as x of n by m and n takes value only when n takes the value 0 plus or minus m plus or minus 2m plus or minus 3m etc. Let us try to write it out. Suppose n is some 3 value, then yun is basically x of n by 3 for n equal to 0 plus or minus 3 plus or minus 6 plus or minus 9 that multiplied by 3 and 0 for all other n. So if you take this, suppose you take another example of n at 0, you have some 5, 4, 3, 5, 4, 2, 6, 2, 1, like this. So to upsample this, what you're going to get is n equal to 0, then n is 0 here, so x of n by 3, so x of 0 and y of 0 are same, so you write the original y of 0, so this point is same as you're trying to write yun 0, you have your 5 here, you will have the 5 here. Then what about n equal to 1? N equal to 1, it doesn't belong to this, so it should be 0. So it will be 0 here. What about 2? 2 also same with 0. What about 3? N equal to 3, this becomes x of 1. So x of 1 go to y of 3. Y of 3. So what is x of 1? 0, 1, 2, 3, 4, 5, 6, 7. Y of 1 is 4. You get 4. At 4, when n equal to 4, it doesn't belong to these values, so it becomes 0. So you get 0 at 5 also you get 0. What about 6? 6 belongs to this, and it becomes x of 6 by 3, which is x of 2. So x of 2 goes to yu2. So is it yu2? No, and you are having 6, and you are 6. So yu6 is the third value. Sorry, the second value x of 2, which is basically third value x0, x1, x2. Third value, which is 3. So 3 comes here. Then similarly you get another 2 zeros, then this 5 comes here. Okay, so this becomes basically the for representing upsampling is this one. If you upsample by a factor of capital M, basically yun, which is the upsample version, is x of n by m for n equal to 0 plus or minus m plus or minus 2m plus or minus 3m etc. and 0 else. Okay, 0x. So this is the basics of multi-rate signal processing. How upsampling and downsampling is done, and the equation. How do you? What changes in the equation or x of n? What happens to x of n when you do the sampling, sampling conversion? Okay. Um, okay. So we shall see what happens in frequency domain in next class. What happens in frequency domain means when xn is upsampled or downsampled, upsampled by factor of 2 or uh, downsampled by factor of 3, you get some yun or ydn. Okay. But what happens in frequency domain? For example, x of n may be having some frequency representation or spectrum represented as x series j omega. Now, how will you find the upsampled or downsampled version of the signal y of n, which is y j omega, in terms of x series j omega? That we will see in next class. Okay. Do you have any doubts in this session? Any doubt, please ask.
No, sir. Clear.
Okay. If you have any doubt, you can ask now. Do you have any doubts? Is it clear to all of you?
Yes, sir.
Okay.
Yes, sir.
Yeah. So I think we'll stop. Can proceed for your next class. So today you'll be having one quiz based on today's as well as last class session. Today's session as well as previous class combined, we'll have a quiz. So you can attempt it till today midnight. Okay. You can attempt any number of times as usual. So it may be questions, maybe 5 or 6, just 5 or 6 questions. Okay. So those who couldn't attend the session due to network problems and all, they can attempt see the video and answer the quiz. Okay. So if you don't have any other concerns or doubts, you can wrap up today's session. Thank you all.
Thank you, sir.
Thank you, sir. Thank you, sir.
Thank you, sir.